Hello everyone, welcome to All About Analytics. So in previous tutorial what I've told you, about simple imputer class in this, that how we can perform missing value imputation through simple imputer class. And simple imputer class is having some drawbacks. For example, if you wanted to impute multiple values in different columns, for example, in one column you wanted to impute mean value, in another column if you wanted to impute median value, in some columns you wanted to impute mode value or most frequent values, right? So you cannot perform that with simple imputer class, right? So for doing this thing, or imputing different kind of values in different columns, you have to use column transformer or pipelining the data. Okay, so doing this, what we have to do is we have to use pipeline class and column transformer classes of simple imputers using Scikit. So let's continue the topic. So these are the necessary libraries and classes which are required: pandas, numpy. This is simple imputer class, this is column transformer class, and this is pipeline class, right? This is my training set of the data, and this is testing set of the data. These are the first 5 rows of our dataset using head function, right? Train.head. I've told you about all these functions and classes in previous tutorials, right? That how you can import them. Okay, then I have created the training and testing sets. As you can see, I have dropped the column target variable. Our target variable is this. Sale price is our target variable, right? And rest of them are dependent variables, and this one is our target variable, sale price. So I dropped the target variable from the training data set. Okay, then I created another ytrain in which I imputed the sale price, our target variable, right? Then I've created the testing set xtest using this data. I've created the copy of this data into this variable, right? Then what I did is I am filtering out the numerical variables and categorical variables also, right? CTE, categorical variables, and finding out that how many numerical variables are having missing values and how many categorical variables are having missing values in them, right? So let's do it. As you can see over here, I have already did 4 numerical variables. Now let's go for categorical variables. I have already told you all these things in previous tutorials, that how you can filter out the variables and select a particular data type, okay, to filter out, right? So what I'm doing is I'm filtering out the categorical variables now, because for numerical variables I have already did this. So cat underscore variable equal to x underscore train dot select underscore b types include equal to list. Inside the list I will pass out that which kind of value I want object type value dot colu minus columns, right? So this will give me the this variable will give me the names of categorical variables inside the data set. So these are the categorical variables which are having these are the categorical variables which are present in our data set. Now I am wanted to filter out that in which categorical variable the missing values are present, right? So filtering out, what I'm doing is I will copy this one. Control C. Cat underscore where underscore miss, right? Cat underscore where listener.sum, if any variable is greater than 0, then show me the name of those columns. Cat underscore where underscore miss. So as you can see, these are the columns which are having missing values present inside them, right? So as we have got, as you can see, in numerical variables we are having 3 columns which are having missing values, and in categorical variables we are having multiple columns in which we are having missing values. So what I am doing is, in numerical variables I am imputing the mean values, right, and mean and median values in numerical variables. And for categorical variables, I have told you, in categorical variables we mostly use most frequent values or mode values for imputation purposes, right? So let's impute, let's create a, let's decide that in which column we are imputing which value, right? So let's choose out the columns first. So num underscore var underscore mean. So I'm imputing the mean values in numerical variable of which column? So for mean value, I'm imputing mean value in lot frontage column of numerical variables, right? So this one is the column. In this column, I'm imputing mean value, right? Numerical car is written over here. Sorry, this is numerical variable, and numerical underscore var underscore mean. Sorry, median value. I'm imputing the median value in this, right? So in these two columns, what I'm doing is I'm imputing median values. Then I'm imputing the categorical variables, cat underscore underscore var underscore mode values. I'm imputing these columns. So sorry. So in all these columns, I'm imputing the mean value. Sorry, mode value. So all the names of the columns have been decided, right? So in this column I will impute this value, mean value. In this columns I will impute median, and in categorical columns I am using mode value, right? Now let's create the pipelining of the data, that how we will impute the values, right? So let's import the simple imputer class. Okay, so let's do the defining part of define pipelining, right? So now I'm creating a pipeline. Right, so in pipeline, first of all I have to give steps. So in steps I give the step name, that's imputer, right? And always remember, this must be in list, right? List, then I have created a tuple, and then I have named the imputer, that which imputer I wanted to call, right? Now call the simple imputer. Simple S should be always capital, imputer, right? Now after imputer I have to decide strategy. So first of all I'm using strategy, and choosing is mean, right? So I'm imputing the mean value first in these columns, right? Let's save this into a variable called numerical underscore variable underscore imputer. Numerical variable mean imputer, right? Now copy this code again and again and use different strategies for each variable. Now what I'm doing is for median imputer strategy, just change the strategy name to median, right? Now what I'm doing is it is for choosing the categorical variables, and this is my mode imputer. Strategy is, in case of mode you can directly write mode, or you can also write most underscore frequent. Both will work as same. Easy? Am I making sense? Okay, let's go to the next part. Right, after defining the pipeline, what we have to do is we have to create a use column transformer. We have to transform all these values into our columns, right? So in these columns we are transforming these values, right? So for doing this we use column transformer class. So let's call this, C must be capital, transformer, right? This is our column transformer class. So inside transformer we have to pass a argument which is known as transformer. Now let's transform each column. So what we have to do is we have to select out the imputer name first. Okay, so first I'm using this one, first one, and this column what I want is so first of all, which imputer we are creating a mean imputer, mean underscore imputer. This is my name, this is the name of my imputer, right? And this is the strategy, and these are, and let's select out the columns. These are the columns, right? This is the imputer's name, right? Mean imputer. This is the strategy of imputer, that how mean strategy is applying on these columns, right? And these are the column names which I have used this. So new dot frontage was the column for which I have chosen the mean values, right? And this way you have to do this for all the columns, right? And always remember, for each imputer you have to use a different tuples inside a list. Here is a list, inside the list is different tuples. As you can see, this is a tuple, this is one tuple, this is going to be the second tuple, and for this is going to be the third tuple, right? In this way. This now next will be my median imputer, median underscore imputer. In median imputer we will use median imputer strategy, right? And then which column we want, here is our column for median values. Right, let's go for, this seems quite complicated, so I'm changing some. Right, let's go for the another one. Now mode imputer, mode underscore imputer, right? So in mode imputer I'm selecting the categorical variables with mode imputer strategy, right? And column name is cat underscore mode, right? So as you can see, it's been done. Now let's run this. So it's, as you can see, it has been executed successfully. Now I'm saving this into a variable called preprocess, right? Now process. Now what it is showing is, it is showing us in which value we are imputing which kind of values, right? So it is showing you this, that you are imputing main imputer in these columns, right? As in this way, strategy mean, right? So let's move on. Let's go to the next point. After doing this, I will fit this preprocess dot fit in which dataset we are fitting it into. We are fitting this into x underscore train. We are doing it for train data, no? Always remember, whenever you are fitting the value in this column transformer, so you will fit this in x train data set. Okay, so let's fit this and run this. Okay, I have got an error that too many values to unpack, expected 3. Okay, just give me some time to solve this error. X underscore train. Okay, so let's continue. So here you can see too many values to unpack, expected 3. It is because what I have did is, here is a silly mistake of mine, that I have forgot to close this bracket, right? Now it will not show any error, right? As you can see, so I have already fitted this preprocessor dot fit underscore x train. So this, all these values which have been transformed by this column transformer, right, have been fit into this x train dataset, right? So let's move on to our next step. Now what I wanted to do is, I wanted to transform all these values, preprocessor dot transform x underscore train. So after transforming all these values, what I have got is a 2D array, NumPy array, right? So what I have to do is I have to convert all these arrays into a data frame first, so that I could get a nice view of dataset, right? So for converting this, what I have to do is, first of all, I would like to check that where are those all other, for example, if you see there, I'm showing you, if you check here, pre-processor dot transformer underscore. So if you see here, so all those columns which are not having missing values have been dropped by this remainder of this, right? I forgot to do this pass through value. Here by default value is drop, right? So in case we have to pass the value remainder to as, in place of drop we have to write pass through. So I forgot to do this. So what it did is it deleted all those columns which are not having missing values inside them. So these are the index number of those columns which have been deleted. They are the columns, right? So first of all, what I'm doing is I am creating a column of I'm creating a new data frame of these, right? So let's create the data frame first of those imputed values. So x underscore pd dot data frame x underscore train underscore clean I'm saving this into x underscore train underscore clean, because these are all clean data set now, right? And same thing I'm applying for the test also, x underscore test underscore clean. So I'm imputing the missing values of our test data set also. Preprocessor dot transform x underscore test. So x underscore train underscore clean, right? Columns, right? Now what I'm doing is I am arranging all these columns in the same manner as I've selected them. For example, first of all, what I've used is I've imputed the mean values, right? So I'm copying the main one. This is my mean column. Then plus, and second, median columns, in which I have imputed the median values. And here our categorical values, right? So as you can see, a data frame has been created, but this data set belongs to only cleaned values. This data set is only of clean values, right? So it is, if you see, the shape of the column is only 19 columns and this in these much of rows, because this is the clean values. These are the clean values which I have on which they are those columns on which I have performed the missing value imputation. But those columns are missing from this because they are not having, because they were not having missing values inside them. So by default they were deleted by the column transformer. So this is a task for you, that using these index numbers, these are the columns index numbers, how you will create a data frame of the using these create another data frame, right? From after extracting the data frame, sorry, let me tell you the method that how you have to do this. You have to do this, you have to extract all those index column numbers which are mentioned below, right? Copy them and then extract all those in columns from this main data set. Okay, create another pandas data frame and merge those, sorry, merge that newly created data frame with this data frame, this one, and in this way you can join both the data frames, right? And your data set will be cleaned. So if you see this new data set extreme underscore missing and check for the missing values, so you will find no missing values inside these columns. Dot is null, dot sum. Shit, always this kind of error. Train underscore miss is not defined. Now if you see here, as you can see, there is no any missing values present inside these columns. All those columns are imputed successfully, right? So in this way you can impute all those missing values using your column transformer class and pipeline class, right? So thank you so much. And if you didn't get anything, or if you are facing problem anywhere, or if you are facing problem in this in creating this merging this one and these data frame of this, so just tell me in the comments. I will provide you the link of this notebook. You can prefer my notebook and create your own solution. So thank you so much for watching the video.